Hi, everybody. Over the next 20 or 30 minutes, I'm going to give you an overview of the work that we're going to be undertaking to identify the essential life support areas. The idea here is to just give you some overview as to how the information that is going to come from the policy hackathon and data hackathon is going to be used to identify these areas. So first, our overall task is to identify essential life support areas at the national level, which if protected, managed, and restored, will support the nature-based commitments to biodiversity, climate change, and human well-being. So you can see there are a number of important aspects we're working towards here. We're working to consider protection, management, and restoration across the country, as well as objectives, commitments for biodiversity, climate change, and human well-being. As we work towards this, we're considering 9 basic design criteria for these areas and our process to identify them. The first is that the process should directly support national policy commitments. And that's why the policy hackathon is the first part of the work. It's a critical step that guides everything else. As we identify the essential life support areas, we need to know what policy commitments have been made in the country, how can we find data and use that data to best support those policy commitments. So this is where we work to design this for the national context and national policy. The next design criteria is that we need to be considering multiple actions across the broader land base. So we're not only looking at protected areas, which are a very important form of managing natural ecosystems for multiple benefits, but we're also considering sustainable management. This could be sustainable agriculture, sustainable forestry, and we're also considering restoration. This could be forest restoration or reforestation or restoration of other ecosystems. And I should also mention when we consider protection, we're not only talking about government protected areas, we're also considering other effective conservation measures. And these measures can vary in different places. Also protected areas, these are not only strict protected areas, but also protected areas which are managed for multiple benefits, maybe some level of resource extraction or ecotourism, some forms of human use, which still promote or allow the natural ecosystem values to be maintained in these areas. The third design criteria is that we will be using the tools and the concepts of systematic conservation planning. Systematic conservation planning is a process that uses spatial data to meet management objectives in efficient ways that promote complementarity across objectives. So this way we make best use of the spatial data as we work towards multiple conservation or land management objectives while considering the efficiency of reaching those policy commitments. The fourth design criteria is that all of our work is spatially explicit. We're looking at managing the land base, identifying essential life support areas across the land base. And it's also, we're working at the national level. So as we look for data sets, we're really looking for those data sets that are available for the whole country and not only for specific regions. The fifth design criteria is really important, and that is that the process needs to harness the national expert opinion and stakeholder values. So this is why the process the international team works very closely with the national partners to harness that expertise throughout the process. And then finally, when we really integrate all that information to identify the essential life support areas, we run a collaborative session or series of sessions, which the purpose is to really bring stakeholder values, and all the participants in those sessions bring their values and opinions and knowledge into the process to identify the essential life support areas. So that's a really important part of the ELSA process. The sixth criteria is that we are working to identify indicative areas. So these are not necessarily precise locations for implementing programs. And really what this means is that even though we're using the best scientific methods and the best national and international data sets, really the resulting essential life support area map does need to be ground truthed, working with local stakeholders and local knowledge holders before moving towards implementation. So the results from this process are going to be a map that can indicate the best or most critical essential life support areas. But further policy work, stakeholder engagement work is required before programs are really guided by this information. The seventh criteria is that we will be harnessing, or we will be working to harness the best national data sets and to use them wherever possible. But we'll bring in also international or global data sets where those data sets are suitable or national data are not available. We also need to consider the hard constraints on the land base. And what the hard constraints mean is basically places which are not available for protection or not available for restoration really can't be considered as candidate essential life support areas. So good examples of this are the urban areas across the country. These are important places where people live and work, and they're really not available for broad protection, restoration, or various forms of sustainable management. So we need to understand those hard constraints across the country and bring in spatial data to map those and include that in our systematic conservation planning. And the final design criteria is that the process and the work needs to be flexible. It needs to allow exploration of how results change under different scenarios before producing the final essential life support area maps. So for this, what we do is we actually create an online web tool that integrates all the spatial data and can run the systematic conservation plan and show us the results in real time so we can start to explore the trade-offs between different objectives, integrate stakeholder values within those sessions, and recreate and iterate the map before we produce the final essential life support area map. I think a very important question early on is, why do we need to use systematic conservation planning and spatial data to help us with this sort of land use planning for protection, management, and restoration? I think the best way to answer that is to use this hypothetical landscape that I'm showing you here. This is a very simple landscape. It's represented by 10 rows and 30 columns. So there's 300 individual pixels, or what we call planning units, within this landscape. Now, if you were to pretend or imagine that you are a land use planner for a region or for a country, it's your first position, and you've been tasked with establishing the best network of protected areas across this region. Luckily, it's a fairly simple region, so you could evaluate different options for protected areas and determine which would be the best one. So in this landscape, I'm showing you one potential network of protected areas. You can see there are about 10 protected areas across this landscape. But there's many other ways you could put protected areas here. You could decide to protect some of these places or other ones instead. So the question I have for you is, how many different potential networks of protected areas are feasible within this landscape? So I'm showing you one, but obviously you can configure it in different ways. How many ways do you think you could configure it in? There's 300 planning units. Do you think it could be 300 different options for how to establish protected areas? Or 3,000? Or 3 million? And you can see if it's a larger number, there's more options, more ways you could establish protected areas here, and it gets more complex to find the best ways. So this slide, I'm actually showing you the true number of different options for how to create a protected area network in this landscape. You can see this number, it starts with 2, and then it's got about 90, or does have exactly 90 different figures or numbers after that too. So there's no name for this number. It is so large. But what it means is that there are more potential ways to create protected areas in this very simple landscape than there are atoms in the entire known universe. So the decision space here, the number of different alternatives to consider, is greater than the number of atoms in the universe. So that just illustrates how for even this incredibly simple landscape, 10 planning units by 30 planning units, there's a near infinite diversity or options for how to manage the land base. And that's, you can see that sort of decision is obviously much more complex than you would initially imagine or guess. Now, most landscapes are much larger than 300 planning units. It's thousands or hundreds of thousands of different planning units. So you can see there's much more options. And also, most landscapes don't consider only 2 different options, as in protect or don't protect. They consider multiple land uses. And that's what we do in the essential life support area process. We consider protection and other effective conservation measures, but also sustainable management, restoration. And you can see that makes it even more complex. And that's really why we use spatial data and systematic conservation planning to bring all the information together and help us find good solutions to these complex problems about deciding the best ways to manage land for multiple objectives. Okay, in this figure, I'm just showing the overall essential life support area process and how everything comes together. There's quite a lot going on in this figure. I'm hoping my mouse is pretty small, but hopefully you're able to see what I'm pointing to in this figure. The first thing to note is the need for considering national policy. And this is really what the policy review and policy hackathon is all about. It's to look through all national policy documents for various commitments which have been made to how to manage natural systems, or how natural systems underpin human well-being, biodiversity, other values. So that first process to really understand that the national policy landscape. From this policy, the first thing that we need to know about is, what does protection, sustainable management, and restoration mean within the country? And where are these actions possible? What sort of places are suitable for protection, sustainable management, and restoration? And then, as part of the data hackathon and the subsequent work, is to identify data sets that can help guide those actions. The next main thing that we need from the policy work is to understand, what are we trying to achieve, or what's been identified in those policy commitments as the important aspects of the natural systems in the country. So from this, we derive what we call conservation features. This is some of the most important data that goes into the systematic conservation planning for ELSA. So depending on the policy or review, we might find that conservation features might be threatened species, or it might be ecosystem carbon, or it might be human well-being, disaster risk reduction from flooding or landslides. And what we do there is we identify for all those different conservation features, we identify data sets, spatial data sets that can reflect where in the country are those conservation features found. And the final process here is to use expert review of those data sets, conservation features, and then also weighting to understand which are the most important or the most critical of those conservation features. And then finally, all this comes together into the systematic conservation planning tool that we develop to and is integrated to identify the final essential life support area map. And in a minute, I'm going to give you a demonstration of that tool and how it brings everything together. Before I do the demonstration, I just want to reiterate that what we're doing here is we're considering multiple actions in the land base. Those actions are broadly defined as protection, which can be protected areas or other effective conservation measures. We're also considering sustainable management. This is often sustainable management in agricultural areas, which could include increasing tree cover, increasing ground cover, and the biodiversity of these sustainably managed areas. And then finally restoration, which might be forest restoration or ecosystem restoration. And for each one of these actions, we're considering within the land base, where are these actions feasible? Through the process, we're going to figure out the best way to reflect that feasibility for your country. But often what we do is we use a map of human development, which we consider which we call the human footprint, which shows us places which are heavily developed and are not really, it's not really feasible to protect these places or restore them, as well as places which are more moderately developed, and these places might be suitable for sustainable management, restoration, or protection. So we need to identify the best way to reflect these hard constraints, as well as spatial data that can help guide us. Okay, well, thank you for listening. I'm going to now do a demonstration of how this is reflected in the tool.